I would like to introduce Klaus Tupke, who will be presenting Clash of the BGP Titans, which open source routes it best. Klaus is a product developer at Telco Manager and has traveled from Brazil to speak with us.
Hello. Good morning, everybody. I cannot see you from here. Lots of lights on my face here, but I suppose everybody is awake, right? So good morning, and let me choose this one. So I need the, it's here. Let's see. So today I'm going to talk about the BGP daemons. My company works for traffic analysis and also with ISPs and enterprises. And we deal with lots of basically routing analysis, sometimes with NetFlow, without it. Also traffic engineering, steering traffic, and those kind of things. So to choose a BGP, a daemon for us is something important because we use lots of other softwares together. So if you just have BGP itself, it's something else. But if you have to integrate with like bunch of other tools, you might need to have some sort of features or some functionalities that might be more interested or not. So that's the reason we have to select. And the matter to choose a BGP daemon is more particular to the organization, your use case. It's not normally, it's a personal choice sometimes. It's like the TED Talk when you see the paradox of choice. You have so many options and you get freeze, you don't know which one to choose. So this presentation is about a methodology, how to choose the BGP. Some of the items here I miss some points. I wish I could put more things, but I will talk through when I'm going through. So the use cases for analysis, this is it's pretty obvious. It's SDN controller, which is going to do traffic engineering, or the mitigation for attacks, or a looking glass for your customer or for your internal company, a router reflector, or a data fabric, if you want to build some sort of a big router with small Linux boxes, you can use this kind of BGP as well. Or to do analysis, right? BGP analysis. So I put some text in the middle, try to chill out, and this is one of the withdraw things that I thought was funny. Someone don't understand withdrawals, right? So the criteria here, it's my choice. I put those items here. So we're gonna go through code, style, flexibility, features, configuration, automation and APIs, security and testing, deployment, performance, which is gonna be the most fun bit on this presentation. And then we are also talking about adoption and community. So that's gonna be the first item here. Here's a little bit more deeper on each of those criteria if you are interested, but we can go straight to this. So in the beginning, when I start searching for the BGP daemons, so which one I'm going to start use, which one I'm going to compare to, I found basically 8. And I put Zebra here and Quagga just because it's historical. When I did my master's degree in 2000, there was only Zebra available as an open source. Even Bird wasn't there. And so Zebra was the first one that I could use to do some BGP analysis on that time. So, and I put it like a table with scoring. So that's the methodology that I use. I put each line is the subject that I'm talking about, and then the columns are the daemons. At the moment, I've got 8. So let's check the adoption and community. Quagga, as I said, and Zebra, it's not, it's dead at the moment, but if you look in the past, it was kind of good contributions, and the last commit was around 8 years ago when I check. So this measurements I done was like in GitHub. Anyone can do that. And those points here was taken on September 2000, this year, September. But I did this presentation before in IX Forum in Brazil. So I have the data here from 1 year before. So we can compare the growth in terms of usage. And Zebra, it has been forked to FRR in 2017. And FRR is on version 10.4.1. And you have 464 contributors today, but used to be 436 1 year ago. So it's around 30 people more contributing to the code. The number of issues raised, and the number of stars also raised by 400. Those are parameters that is a good point for you to check if an open source software is being used and has more people contributing or not. So then if you have an issue, or if you're interested of having a new feature, well, probably it's going to be easier to do that with a bigger community. So the number of people watching reduced to only, and the number of forks also raised. And when I checked, the last commit was just 42 minutes. So it's very frequently updated. And in terms of the code, it's basically 70% C and the rest is Python. This number changed in 1 year, so it's more Python now than C, but it's a small change. On the other hand, we have GoBGP, which is newer than most of the others that I've talked already. And it started in Japan 2014. And in terms of contribution, it also has a growth in 1 year. It's around 20 people more contributing. The issues also raised by 20. And the number of stars also raised by 300. Less people watching, and there are more forks, around 751 now. And when I checked, it was around 2 days last commit. The license is Apache 2.0. And Go has raised in terms of percentage, so it has more Go than Python in the code. And then comes Bird, which is, it's older than most of the other daemons in 1999, and now it's on version 3. Has 38 contributors. I raised 3 contributors from the last year. There's no issues when I checked, which is amazing, no having any issue. And stars are just 148 stars, but it's a quite big change from 92 to 148. 21 people watching and 38 forks. And the last commit when I did the search was like 2 weeks. The license is GNU version 2. And most of the code is in C, and also there is the Perl there over, which is kind of interesting. Now let's talk about the GoBGP daemon. The idea was to overcome the security issues with Quagga in 2016. And it's not a many people contributing, which just 7 people. We raised 1 and 7 issues, maybe 1 issue per person, and 65 stars, and 9 watching, and 18 forks. When I checked, it was like 3 weeks the last commit, which is kind of frequent. You can see the frequencies on the graph underneath, which is the GitHub contribution over time. Most of the code is in C. Then comes ExaBGP. ExaBGP is also quite newer than the others, and it's API-driven. Has around 110 contributors, which raised last year, and 2,200 stars. But there are quite a few forks on it. It shows for the number of the contributors, there are lots of forks, which is quite high in terms of the percentage of contributions. And it has its own license based on the PSD3. And most of the code is Python. Then comes Holo-Routing, which is the new kids on the block. It's developed by Renato in 2013. 23. It's quite new. Has 9 contributors, raised 2 from the last year, and has 11 issues. 400 stars, which is a lot of stars for a small number of contributors. 16 people watching, 31 forks. The last commit was like 5 days when I checked, which is pretty good in terms of people working on it. You can see the graph as well. And 100% is on Rust, which is quite amazing how someone can implement everything in only one language. I would not do this, but it's person for each project, right? So then comes RustyBGP. RustyBGP has no version and no tags, which is kind of weird. And then I checked, because last year I checked and was kind of contributions on the code, but it looks like for 9 months nobody contributed to RustyBGP anymore. And then it looks like it's the same project as GoBGP, but written in Rust, and to implement BGP. It's 92% of Rust, the rest in Python. So for our score here, Quagga is dead and becomes FRR. In terms of the score that this is a kind of personal, right? I put 10 for FRR just because there are lots of people contributing, and the community, it's pretty big. And then comes GoBGP with ExaBGP, which also has higher than the others. The one that impressed me here is actually Holo-Routing, that raised a lot in 1 year. Okay, so code style. This is completely personal. Apologies for my points here, if upset anyone, but it's completely personal. Each person is going to say something, and this is my methodology, right? I put some points. If the language has too many languages, it's too spread and too complex, I put less points, just that. So FRR, for instance, has also Perl, but it's a small percentage comparing to the Bird, for instance. But it also has a different languages like GoBGP, Bird, OpenBGPD. So I give half point for those codes, and the one that was just majority of one code, which was like ExaBGP and Holo, was like getting 1 point. The style, I would like to give more points for new languages, right? So Go and Rust get more points. And I get 1 point more for OpenBGP daemon for security reasons. They care about that. And 1 point interesting here is those routing tools, some of them just support BGP and others support other protocols as well. So like FRR supports other protocols, and Bird and Holo-Routing. So those 3 get more points just because they have extra routing capabilities. In terms of plugins, most of them and the newer ones have. And ExaBGP is API driven, so and Python has lots of tools, so it's easier to do it. And half points for FRR and Holo-Routing. In terms of age, I'm gonna be a little bit nasty here, but I'm gonna put more points for newer implementations. So old ones not gonna get any points, unfortunately. This is just because it's super hard to maintain. So for instance, Bird here is the oldest in the but it's amazing how Bird performs. You're gonna see later. Even it's an old code. I mean, not an old code, but old project, let's say. But it's amazing how they perform. I'm gonna show later. In terms of flexibility, I put some codes here, like in terms of API support, and those are my points. I normalize to 10, and then gets the results. So in terms of code flexibility, Holo-Routing gets here the most points. And then comes GoBGP, and then FRR. The next one is going to be about configuration. Configuration usability. This is also personal, right? If you like Cisco syntax, you're going to like FRR. If you like Juniper syntax, you're going to like maybe other tools like GoBGP. So it doesn't take very factual, it's more subject. But in my case here, the format, it matters if it's maybe something complicated like HTML or XML, but most of them has some sort of format. FRR, it's based on Cisco text and also has a JSON API. GoBGP has gRPC. Bird is text-based through CLI. OpenBGP as well. ExaBGP is just Python. And Holo-Routing is YAML with netconf. And RustyBGP also YAML. I put some easy points here based on my experience testing. So the green ones get more points. In terms of documentation, that is something which I think it's a good thing to have, and FRR and GoBGP has a lot. Some of them might not have, maybe because I didn't find it properly or I didn't do a good search, but that's what's my results here. In terms of tools, I evaluate all the gRPC capabilities, so I put green points there, and also Python integration for the ExaBGP. And so for command line interface, those are the tools used. ExaBGP doesn't have a CLI. You have to write your commands in Python and implement. But most of them has some sort of a CLI too. Some are easier, some are not. But this is also because of the documentation, probably. If I had a better way to see how things work, I probably would get more points there. The syntax, I put the green one for the common styles. Bird, unfortunately, has a bird style, which is different. And for dynamic changes, most of them implement, but there are few things that you cannot, you have to restart. I have not tested all of that, but those are the points that I put for this methodology here. I might be wrong in some of them. So for this, I got 10 for FRR and 10 for GoBGP. And let's go to automation and API. In this case here, I think gRPC is the way to go. And RESTconf and YAML and netconf, right? So Bird doesn't have it, OpenBGPD also doesn't have it, and the Rust have. I put the green ones for the ones that has gRPC. RESTful, RESTconf, YAML, most of them don't have it. And dynamic updates via API, most of them have. So again, FRR wins and GoBGP. Let's go to another very, I made some mistakes here. For instance, Bird supports our KPI, so I did a wrong update on this slide here, couldn't. But anyway, this is the methodology here. I choose some of the security aspects and I put it here. So ExaBGP lose on all of them because it's not intended to do that. So you lose points there. And let's go to the next one. So the score here for security, it's basically FRR, OpenBGP daemon, and GoBGP. BGP features, that is a very hard to measure. It's almost impossible. There's so many RFCs and so many standards for BGP that it's unfeasible. So I decided to look on a few of them, those RFCs, and I scan the code or I scan at GitHub if there was some documentation of those RFCs. That was my methodology, which might not be correct, because if someone didn't put the RFC code there when they were documenting the code, I'm not gonna pick it up. So I didn't try to configure, I just searched for this implementation documentation. And for those search I did, the most of them has leak prevention and route optimization, but flow spec doesn't look like they have on the Holo-Routing and RustyBGP and OpenBGP daemon. The rest have. And you want that for some sort of steering and probably denial of service mitigation. GNMI also that I think it's important. It's not many have, just GoBGP and Holo-Routing. And FRR supports as well. EVPN and segment routing, also not many. So in this score here, GoBGP gets most of the points, and is second FRR, and then Holo-Routing. Deployment and operation. I think one important thing here is how we can deploy that, right? So in my tests, I've done a Docker container for each of those BGP daemons, so which is easier. So you can add all the libraries and necessary things in just a small container, which shows how much in terms of footprint you're using. But it's interesting to know, like, that some have lots of binaries, like FRR has several binaries, and GoBGP is just one, and Bird as well. So it's interesting to know. And then I put some points here for the binary structure and the resource footprint. So one of the very high here is ExaBGP, but it's because of Python. And BFD also, it's wrong. Bird has BFD, and I missed here. So I might have to search again BFDs here. And graceful restart might not be correct. And for those, I put the points here, and then Holo-Routing 1 for 10, and then second FRR. And those are the list of the major crashes for humans. Which means we need to make daemons intelligent and run some sort of automation to avoid those kind of things. And the choose of the BGP might be the way to go. So now I'm going to get some of the most interesting part of the presentation, which is about the performance. I wish I could have more time to do other tests, like number of search per second, or number of misses per second. I've searched in the table IP address that doesn't exist, or I searched one that exists. Maybe put lots of metrics on each route and differentiate to see if they choose the best path easily or not. Unfortunately, I couldn't do that because of the time I had. So I decided to do a very simple methodology for performance. I created 5 million routes in one, well, let's say, router, and put it inside a container. And then I connected to another container using VEF, which would not introduce any bandwidth limit in terms of network. The machine is 24 cores, 128 gigs RAM. And the idea was to test when I put 5 million routes and connect, how long it takes for the router to update itself and have those 5 million routes. And also then I shut down and see how long it takes to clean up the memory of that allocated 5 million routes. So this is not a best approach to testing performance, but is the easiest and fastest way that I could find. Those are the images I used. Some of them I built really easily from the GitHub. I had to recompile and create my Docker file and build it and create my Docker Compose, and I didn't measure that, but most of them here are around 100 megabytes. You see that the smaller here is a GoBGP, but it's also only one daemon, and RustyBGP. But also the OpenBGP daemon is just 20 megs. It's FRR, we're using 192, but lots of daemons on there, as well libraries and also ExaBGP, which it's consuming around 140 megabytes in terms of memory of the image, right? So how was this test done? FRR I tested first. When I turn on, it took around 130 seconds to come up with the full 5 million routes. And the memory initially was 23 megs and raised to 9 gigs. And I measure also the bandwidth on this VAF interface between the two Dockers. And the interesting thing here, it's limiting around 24 megabits per second because the server is just holding up. And the number of cores on FRR was around 3, maybe 3.5 in average for this 2 minutes interval where you get the full routing 5 million entries. And then I shut down to see what was going to happen. It took around 90 seconds to come from 9 gigabytes of memory to 100 megabytes. This is maybe some implementation internally for garbage collection or something that freed the memory. It's not as important if you think about it, because you're not going to have a whole drops. Normally you have, a few routes coming in and out. It's not frequent, but I wanted to test if this open source has some mechanisms to, deal with this problem easy or not. So that's the methodology I use. I just shut down the interface, and you see it took around 90 seconds to free memory. But it didn't come back to the 23 megabytes initially, which is fine, but it took 90 seconds to free, and used a bit of CPU as well, around, and 2 cores, around that for 90 seconds. And then comes GoBGP. The last time I did test with GoBGP, which is like 1 year ago, the performance was way better. Now it's way worse. And I don't know what they did, but this version doesn't perform as well as the previous one. Which makes me wonder if I have to be doing this every year for my tools to see if one is performing better and then switch between one and the other. But anyway, GoBGP took around 150 seconds to get 5 million routes, and it started for 89 megabytes to 5.5 gigabytes, which is more allocation than the previous one, right? Which was, FR using more, right, 9. And GoBGP, in terms of allocation for those routes in the memory, is a little bit more optimized, use almost half of it for 5 million routes. And the bandwidth is around 20 megabits per second on the VAF. Here was 24. The reason is because it took a little bit more time to actually get the 5 million routes, 30 seconds more than FRR. That's the reason the bandwidth is also slow, right, in terms of the other one. And then shut down. And then something weird happened. The memory raised from 5 gigabytes to 7 gigabytes. And then I said, oh, that's weird. And it didn't come down. So I keep monitoring, and after 4 minutes, it drops to 2 gigabytes, which is still a lot of memory with no routes. But anyway, so that happens. So if you're planning to use GoBGP and you have some sort of, transients, you have to be careful of memory allocation, how it's working or not. Maybe it's a good thing to always keep looking at it. And after 6 minutes, it dropped again. Maybe some sort of garbage collection coming after a while, but then drops for 500 megabytes. And then I did a gRPC query wrongly, and GoBGP dead. So I think this is a very bad thing, because GoBGP, I've been working with GoBGP for maybe 5 or 6 years since, and always have the same problem. If you use a wrong call on gRPC, you're going to kill the server. That's the way. And then comes RustyBGP. RustyBGP was interesting. When it turned on, connected to Dockers, lots of network, just like 5 megabits per second without stopping. I had to do some TCP dump and see what's going on. And actually, is a TCP trying to connect the BGP without any resting. So it's like every almost like 655, like maybe less than 1 millisecond, it keeps trying to connect to the neighbor and creates a huge network without any necessity. So this is kind of a bug, right? And if it's a bit annoying, that creates a lot of network and keeps using this CPU, one core up all the time, just to handle these queries, to try to connect to your neighbor. So I suppose this could be maybe easily fixed by some wait there or some timeout or whatever, which is not that difficult, but nobody did. So, and as I saw before, RustyBGP is around 8 months without updates, so they are in a bad shape here. But anyway, I put the connection up, and as soon as the connection comes up, the table goes up really quick. So the bandwidth goes to 58 megabits per second for transfer the table. And it's also very optimized in terms of memory. It just consumes 2.4 gigabytes. Compared to FRR, it's almost 5 times less for 5 million routes. And also came really quickly in terms of 80 seconds. Use around 5, maybe even 10 cores, which is most consuming core of them. But anyway, it came really quick. This is a good thing. If you wanted something faster, to handle faster problems, maybe this is going to be a good implementation, except you cannot have a BGP down. You're going to have that garbage traffic there. Then I shut down. It took a spike of CPU to clean up the things, which was pretty good. So it cleaned the memory really quickly, like RustyBGP was amazing, like 2 gigs for 200 megabits. And the CPU was just a little spike. But then come up the spurious traffic again, around 500,000 bytes per second, 4 megabits, continuously going to the network, or like on the VAF interface, which is annoying. Then comes Bird. Bird, for me, is the most performatic of all of them, and I'm going to show you why. So it took also 5 seconds compared to RustyBGP. Use less cores, just 1 core. It's amazing how performatic Bird is, because it just used 1 core and then got 5 million routes. And again, the final memory is 2.8 gigabytes for 5 million entries. When I say 5 million entries, right, imagine if you're using you're planning to have one of those daemons to control your network as a SDN controller. You need to learn all the paths. You're not going to choose the best paths. You're going to choose all the paths. You have like 10 border routers, each with, I don't know, 10 BGP, eBGP sessions. You're going to have a lot of paths. And the idea here is to simulate this kind of behavior. So 5 million paths here on this, but like 5 million routes, right? But Bird was really optimized in terms of memory and CPU. And the bandwidth shows as well that it goes to 80 megabits per second, showing that really quickly get this full route, sorry, this full 5 million entries. Also releasing, also use a lot of, just a spike of the core for releasing and release memory quickly, 20 seconds. So Bird 3.1.3 was amazingly fast. I tested the previous version, the version 2, was actually even faster than this one. But I'm testing here the last version. So this is a little bit slower, but it's still very performatic. Then comes Holo. Unfortunately, it doesn't have much performance in terms of getting all those 5 million routes. I talked to the developer, and he said the project at the moment is more focused on the IGPs for now. So BGP is going to get more traction as more contributors comes in. So if anyone want to contribute for Holo, please come and help, because it's a nice project and it's written in Rust, which is a new language, has lots of advantage. But this is the numbers, right? It took around 190 seconds to come up with 5 million routes. And the strange thing here is took a little bit more time than actually the network. You can see the graph, the last graph on the bottom is the bandwidth of transferring the data right between the two Docker containers. And it took around 150 seconds to propagate all the routes. But then the CPU kept working for maybe more 40 seconds. I don't know what it's doing, but it kept working for 40 seconds, then the CPU went down. But the memory is steady on around 9 gigs, which is not good. And then I did a show state. I did something wrong on the CLI, and then kaput, it dies again. So also needs some improvements in terms of protection, in terms of bad users like me. The cores went up, and the memory went up as well. And then the queues of all the updates and go to 42 gigs, which was weird. So Holo needs some improvements in terms of those BGP problems, right? And one of them is this one here. And the bandwidth and the memory was high for 42 gigabytes. Then it drops to 32. Even though the shutdown didn't solve the memory is still on 32 gigabytes, which unfortunately it's a lot. And it's the worst from all of the others in terms of memory. And then comes OpenBGP. The OpenBGP has the idea of having more, I mean, in terms of security, and in terms of performance, it's not as bad, right? It took 130 seconds, around 1.5 cores, which is not as performatic as Bird, but double the time, and 3 gigs of memory, around 30 megabits per second in terms of transfer, the table, the 5 million entries. Coming down, it's pretty good. It comes from 3 gigs to 60 megabytes in terms of memory, and took around 20 seconds of CPU to clean up that mess in the memory, which was pretty good. Then comes ExaBGP. It's important to understand that ExaBGP is not intended to what I'm trying to perform here, because it's actually a library to inject routes. However, if you want to do SDN controller, or if you want to check if the routes you're injecting has any effect on your routing table, you need to have a feedback. And ExaBGP is not good for that. You cannot inject and return things. You're going to have routing policies on both ends to avoid having many entries on your ExaBGP, because ExaBGP cannot handle many. I don't know how many can handle, but I'm going to show you how bad it is. So after 3 minutes with the memory up, again, Python is not a multi-thread proper language. And the implementation here, you could use maybe multitasking, but it doesn't. Probably because it's a BGP. And so use only one core all the time, which is particularly common in Python. And the memory keeps going slowly, and the bandwidth is steady around 2 megabits per second. So after 3 minutes, you have 500,000 entries. So it's 1/10 of what we want. And after 6 minutes, 100, we got around 1 million. And after 12 minutes, we got half of the way. And it finished with 20 minutes to get 5 million entries. And the CPU went down, and the memory is around 10 gigs, which is it's quite a lot for 5 million entries comparing to the others, which is like 2 or 5 times more. So again, ExaBGP wasn't intended to do that, but it's important to understand that ExaBGP, for feedback of the BGP sessions, where you're injecting and what you want to receive, probably not going to work as you expect. This is shut down, which was very weird. The memory kept on 10 gigabytes and doesn't do anything. And after a while, I enable again, and then the memory dropped. So it looks like the implementation, if the enable goes down, still allocated the memories, and if maybe memory comes, the neighbor comes back, it frees that allocation, and then comes back all over again. So it just, again, it's not that difficult to fix that in the code, but it's a bad implementation. If you have a shutdown in the interface, you still kept that memory allocated on the memory for I don't know how long. I didn't test it, but was there 10 gigs for forever. And then when I turn on again the BGP session, and then the memory was freed, and then start growing again. So in terms of performance, we've got here a pretty good winner, which is Bird, which is less time, less CPU, free memory really easily, and got most of bandwidth. So I put like the 5 points here for Bird. The second one was OpenBGP daemon, mostly because of the free memory and also the bandwidth and the CPU. And then comes the third, which is RustyBGP. It has that weird behavior if you don't have any sessions established. So like it keeps sending traffic, which is bad. Unfortunately, Exa got 0 here in terms of comparing the others, but it's, again, not intended for performance. And GoBGP was bad, and Holo-Routing I put bad as well because they kaput, they just died if I did a wrong command. I mean, we need to prevent bad users like me, and it's not a good thing to have a, relying on a BGP daemon that might die because of a user. Anyway, so in terms of performance, we got the Bird here on the top, and definitely it was the best. So, the results, and what we can take from this, right? FRR1 here on my humble methodology here, but depends on how you define your methodology, you're going to get different points here. So for this methodology that I'm presenting, FRR1. And then comes GoBGP and Holo-Routing as the third one. But again, it's not that important. That table, it's more important what you experience with and what your use cases are. If you love Python and you know Python like upside down, ExaBGP is your uncle because it's just super easy to integrate with Python. But you want a small footprint, like small boxes, small CPU, small memory. Bird is your choice. It's going to go really quick, and it's going to make things more performatic. But if you want documentation, support of the community, you're going to go for FRR. FRR is the most used one. And probably is a choice if you want other routing protocols as well. GoBGP may be in second, and Bird as well, because it has all of those daemons for other protocols as well. In terms of gRPC, which I'm I suppose might be the proper way to do it in the future. Still not seeing much traction in the other, but anyway, I believe that is the way to go. GoBGP and Holo have that plenty, but the others might not be difficult to implement, but anyway, you have to help on them. So if you think C is your garden, you go to Bird and OpenBGP, which is mostly implemented in C. And if you all want to build your own router, which is going to have all the routing protocols, IGP, BGP, or whatever, you go to those three ones, FRR, Holo, and Bird. If you want to contribute to the project, Bird looks like there are not many people contributing, and is actually a pretty good project. And also Holo-Routing, which is quite new, using a new language with Rust, which is another place to be contributing. So those two daemons, the Bird and Rust, Holo-Routing, would be a good place for you if you want to contribute with the code. Except that, in my personal life, I love to surf. I should have said that before, right? But in the end, you know. And I like acro yoga as well. I don't know if anyone likes acro yoga here, or it's just me. Yeah, nobody likes acro yoga. Anyway, I also like martial arts, BJJ, Muay Thai, box, so don't mess with me. Those are my details. If anyone has questions, please come over. I would love to have a gift to give you, but I don't have any. If you have a question. I can't see your face, but I'll try. Oh, hello.
Hey, good afternoon. I'm Darren Carroll with Quad 9, and I appreciate your methodology, and it supports my biases, and we run FRR. I don't think you stated what your preference is after going through all of this. You know, clearly FRR might, be the leader for, a stable, mature company, but what is your preference?
Oh, yeah. My preference is Bird. I use Bird. I prefer that. But if you are not familiar with CLI things and, a proper language of Bird, I use a lot of GoBGP in the past. Now I'm using more Bird.
Okay.
But the reason is the performance.
Certainly a good reason. I've used
right.
Zebra, Quagga, and Bird in the past, so it's interesting to see the other newer BGP daemons.
Yeah, the Holo-Routing is an amazing project, and it's maybe in 1 or 2 years it's going to be, taking over.
Thank you again.
Thank you.
Hi.
Oh, hello.
Chris Woodfield, affiliated with myself. I wanted to, what I believe is a correction from one of your tables. Now, your experience with Bird is a lot more recent than mine, so I could be wrong on this, but I don't believe it's correct that you have to restart Bird to add a neighbor. There's no way to do it with Bird C, but you can update the configuration file and then sig up, and that should not interrupt existing
Yep,
neighbors.
That's correct. Yeah, I apologize for those mistakes, but you're right.
All right.
Probably I did not do the test properly.
Yeah, thank you.
All right. We'll make it quick here. John Alcock, network engineer for Highland Telephone. Have you thought about doing any of the testing on Microtex or any of the other ones? I know they basically use some version of FRR Bird or whatnot, but have you thought about maybe next year or whatnot, looking how those devices do, and what were your recommendations?
Yeah, that's a good idea. I think that's a great idea. Actually, I was thinking about creating a library maybe for testing, because we do have in Linux, right, memory testing, or maybe there's a library you can just hook up with a BGP and do lots of tests. The thing is, for those devices to test the performance, you might have to be inside of it or have to bring it as a VM so you can look holistic in terms of CPU and memory. In my case, I could bring everything as a Docker container. So as a Docker container, you have the whole view of it, like memory, CPUs, network, everything. Maybe some of those devices, you might have to run a VM, and maybe you can do that. But it's a good suggestion. I might do it in the future. Thank you. Anyone else? We cannot see anything from here, right? Thank you, guys.